Hello and welcome to the February 18th, 2021 edition of ATG Free Webinar Series. This is Map and Target Your Civil 3D Corridor with Ease. I'm going to be your host, Brian Tanner, Senior Technical Specialist with ATG. Thanks for joining us today or on the recording later on. Pleased to have you here with us and talk about some of the ways that we approach Civil 3D targeting right out of the box, and then maybe some other tools that you could take advantage of later on as well. A little bit about myself. Again, my name is Brian Tanner. I'm a senior civil technical specialist. I'm based out of my hometown, or out of my home location of Mishawaka, Indiana. I'm one of a few of our technical specialists who works remotely and gets to work with individuals and firms and organizations all across the country. I'm a Civil 3D certified professional and Autodesk certified instructor, Greenroods sustainable transportation professional. I've been a longtime contributor to the AUGI Autodesk User Group International magazine. I previously had run a couple user groups out of Indianapolis before moving up here to Northern Indiana. My product expertise lies within AutoCAD, Civil 3D, InfraWorks, storm and sanitary analysis tools, Subassembly Composer, Dynamo for Civil 3D, Navisworks, and Bluebeam Review, all softwares that we work with and consult with here at ATG to meet your organization's needs. I've utilized that experience and these tools on projects for over the last 15 years, pertaining from anything from municipal road and utility projects, recreational projects, county drainage projects, state DOT work, including interchanges and major highway projects, institutional expansion, and commercial site design and warehouse site design. So I hope to bring some attention to how these tools that we're talking about today meet those needs across any of those, really any of those disciplines within the civil engineering profession, and hope that you can find a way that it applies to the way you work as well. Let's talk a little bit more about the subject at hand, Civil 3D corridor targeting. We're obviously going to jump into the software. We're going to explore some of these tools, and we're going to do that live as part of this webinar. But for those of us who are joining us that are fairly new to Civil 3D or brand new to it, or maybe just doing a refresher after you've had some training in the past, hopefully some of these baseline fundamental concepts will help ensure that we're all on the same page. Civil 3D corridor targeting is handled through our subassembly geometry. It allows us to have variable widths and offsets for the placement of our subassemblies, as well as the overall dimensional width of those subassemblies. It also allows us through the slope and elevation targets to hit certain vertical elements that need to be applied in our projects. Those could be lane widths, lane slopes, sidewalk widths, back of walk elevations, daylight tie-ins, things of that nature. It also allows for us through targeting to have conditional targets. Some of us may be more familiar with our cut and fill conditions, where we aren't really defining anything in the plan geometry of our corridor. Civil 3D is making those decisions on our behalf based off of our inputs of the cut and fill corridor subassemblies, and based simply on whether or not we are above or below grade where those conditionals hit. What we're talking about today is the conditional horizontal target, as well as our conditional width and offset targeting. And there's that additional slide point about providing conditional subassemblies and their ability to produce target found and target not found entities within that logic of our assemblies. Civil 3D corridor targets are also able to be produced from a variety of different geometry in the file. Whether it be a physical geometric target or it be a conditional horizontal target, we have alignments, feature lines, survey figures, and polylines, which can be utilized for the production of our horizontal information, as well as profiles, feature lines, survey figures, and 3D polylines for our vertical information. Whenever we set those parameters, our dialogue is going to look very similar to what we see over to the left, or rather over to your right, with a drop down that most folks who are getting into it for the first time quickly identify as your toggle between Civil 3D alignment model geometry versus your more static but intelligent feature line, survey figure, and polyline entities. And certainly once we create those targets, even the most basic fundamental AutoCAD polylines become very intelligent and a very integral part of our corridor model. A little bit more about it. Corridor targeting is set by region. You're going to have folks who tell you very different approaches to that, setting all of your targets up first that are basic and universal to the entire corridor, and then splitting your corridor into multiple regions whereby you target individually for those separate regions and their purposes within the corridor. The geometry that you're targeting to can be set from within the corridor properties dialog, or you can use the contextual ribbon of the menu and use the modify region panel for modifying your targets and setting those targets on a per region basis without having to get into the corridor properties dialog. It does require for the geometry in the drawing to select for horizontal and vertical alignment and or conditional decisions to be made. So there has to be something physically available for you to select inside your drawing to define those horizontal and vertical offsets, as well as those conditional targets. One last slide, I believe, before we jump right into the software for those who are patiently awaiting and looking for some more advanced tools. Corridor targets can utilize geometry through an X reference, but while this can be extremely helpful to reduce duplication of geometry between a base file and the corridor model drawing, it also requires some consistency and really good communication between the individuals on your team. If it's a project where I'm doing the baseline work while also working on the corridor, I'm going to inherently know where I need to break my line work into different segments so that I can target the geometry differently between my regions. It's also going to make me more dramatically aware, more distinctly aware of how important that baseline work in the X reference is. I would edit a polyline rather than deleting it and replacing it. Additionally, if you've got that X reference in your drawing and you're using that as a basis of your targeting, whether it again be horizontal or conditional information, you absolutely have to make sure that you never delete or detach that X reference from your drawing, or all of your targeting will be lost from the corridor as well. These are nuanced things for those who I would say are maybe more advanced users and identifying ways to eliminate duplication of geometry between that base file and your actual corridor model. But you absolutely have to keep these things in mind before you go and start targeting for your corridor and end up with serious ramifications in your project later on. So let's jump into a little demonstration of how we handle our corridor targeting inside the software. Right off the bat, we have our simple corridor in this drawing data set. If for any of those who've used corridors in the software, you know there's a few basic principles that we have to follow. We have to have certain types of entities to produce that corridor to begin with. And whenever it comes to corridor targeting, one of the most basic aspects of it is targeting to a surface. So we have to have an alignment and a profile, or alternatively, a feature line. If we go to create a corridor, we certainly have those options within the last few versions of either having an alignment and profile or a feature line representing both our horizontal and vertical baseline. We certainly have to have an assembly, and ideally we'd also have an existing surface to tie back into. For those that I talk to and train with and consult with regularly, I also like to talk about the aspect of we don't always tie into an existing grade surface. We many times have phased projects to where what used to be a proposed phased one surface becomes our new existing surface, and we have multiple phased existing surfaces to tie into. So please keep that in mind. There's no universal rule that your volume surface that you tie back into and that you daylight into has to be an existing grade surface or an existing site surface, regardless of the terminology that you specify. Let's select the corridor and look at some of the things that are currently targeted within it, because while it's fairly simple, it's a fairly simple corridor, and we're going to talk about some fairly simple principles early on. We're going to quickly ramp up, and I want to make sure we're all on the same page. The corridor itself, we could go to the corridor properties like many of us are used to, and on the parameters tab, we can evaluate the various targeting information that we're referencing for the entire region. Well, there happens to only be one region in this particular corridor right now. So if we set all of our daylight targets here, left and right, that's the only targeting that's currently applicable to this corridor. If I start to set my width and offset targets, if I start to set my conditional targets inside this single region inside my corridor, then those are going to hold through if I ultimately split my regions. So let's really quickly, since our targeting is based by region, let's make sure we're all looking at the same region here. One single region for this corridor entity. If I go to edit targets, Civil 3D is going to prompt me to select inside that region, even though there's only one. And we can alternatively from our corridor properties dialog, we can in our contextual target mapping dialog, define right offsets and left offsets and things of that nature. So just by default, I know that this corridor and the stationing is, for the alignment associated to it runs from south to north. And if I select my inside right lane, I actually have an offset and widened alignment that I might choose here. And if I'm not even sure which side it's going to be on, I have a right and a left. It makes it pretty obvious, but we can always select from a drawing where our actual alignment geometry or subsequently our feature or polyline geometry is. So we select it, confirms that it is in fact the right side and add, and we have a right lane geometry. And just as the most basic of understanding of how our targeting geometry works whenever we go from one region to multiple regions. If we have that target set in the primary region and we split our regions at a set location, when we go into our corridor properties and our target mapping, we're going to notice that in both of those regions, that alignment, which happens to be consistent inside of both region limits, is already set. And for the sake of everybody's visibility here, I'm going to stretch out my target mapping dialog so we can all be on the same ability to view the contents inside each of these columns. So that one alignment that was established as an offset alignment, or rather a width target for that right lane, is now established within both regions that have been split. I'm going to come back and I'm going to reunify my regions just to ensure that we are all talking apples to apples for this project. Okay, back to just a single region. It'll simplify some of the discussion that we've had. As long as we understand that a split region will retain the targets that existed from the original region, then we're good to go. We have some additional targets that could be manually be set up for this very basic corridor. We have some additional targets on the left side for a turn lane. So left inside lane that needs to target the left alignment. I won't bother with going into the drawing space this time around since we explored that option the last time. We'll just simply add it and say okay. We can keep jumping in and out and observing those additional conditions that are being met as we apply those widenings. Additionally, we have some conditional subassemblies that need to be applied on both the left and right side for drive approaches. So we have some AutoCAD polyline geometry that represents the limits of drives on both the left and the right side. So we need to define those conditions inside of our corridor targeting. Since we're all in one region and we're already in the target mapping dialog, we'll go ahead and on the right side, find our target not found, curb and gutter right, switch from alignment object type to our feature lines, survey figures, and polylines type, and select from a drawing. And we can simply select those targets, those two polylines that represent the limits of our drives on the right side. Same thing on the left side. And for those who have done this several times before, you know that I've messed something up already, and trust me, I've done it on purpose. For those who are still picking up on the software. So I've got the targets for my limits of drives on the left side of my corridor set. Now, okay to approve those and say okay again. And I have drives applied. But more than that, I have some other issues. I don't just have a drive, I have missing information, I've got conflicting information. What's that all about? Well, whenever we look at our assembly and the coalition or the collection rather of our subassemblies, we have to think about the logic that goes behind it. This roadway has a very simple cross section, single lane, travel lane in either direction, aside from those adapted turn lanes at the north and south ends of the road, those right turn lanes. But we also have conditional target found and target not found horizontal target assemblies. And with those, we have conditions that are what we might term as normal, being the target not found, where we have a curb and gutter, tree lawn, or a boulevard, whatever terminology you want to use, sidewalk, a shelf, and then a daylight. The other condition is where we're adapting for a drive. And this is more than just a little basic drive. It's actually the drive approach with a flattened out 2% section for where we overlap with our sidewalks. So we retain ADA capability and compliance. And then a drive that's going to ultimately daylight out to your existing or right of way if it's a reconstruction project where you're building out your drive approaches to the right of way limit or to whatever set elevation you have for your site grading. You're going to have some kind of horizontal and very likely vertical geometry that your drive approach needs to tie into that we can set those targets for. And we've got the same thing on the left side. Again, a fairly basic, straightforward assembly inside the software. Well, when I was in my corridor targeting, I used the logic of applying a conditional assembly, a target found, or sorry, a target not found on the right. I did this in two opposing ways so that we could see it in two opposing instances, to where the target was found on the left and the target was not found on the right. And what did Civil 3D do? If I spin my object viewer around and I zoom in to where those targets were placed, I know everybody loves the object viewer, we can see that where I chose only the target not found conditional, it just stopped producing my curb and gutter and my sidewalk and my daylight. And where I chose only my target found, where I wanted it to produce my drives, you can see that it's producing both the drives and the curb and gutter, sidewalk, and daylight. What's often overlooked inside of our conditional subassemblies and the conditional targeting inside of Civil 3D is we need to tell it to both start drawing our conditional target and to stop drawing our target not found. I've had plenty of people ask me in the past, why can't Civil 3D just automatically understand if you have a target found that you should stop building your target not found? And while I understand that sentiment, we also have to appreciate the flexibility of Civil 3D. Your target found may have nothing to do with the existing geometry. You may have a target found that represents a fence line or a retaining wall 50 feet away from your edge of or your back of walk in this scenario. And that target found is representing just a short station range in which that condition is applied. So you can have a target found that coincides with a target not found, to where you're still building your curb and gutter, you're still building your sidewalk, you're still building your daylight, and then out in space at an offset marked point, you have other geometry that actually is going to be drawn during a target found space. The same thing may apply to a ditch line. Again, the assembly that we are using in this example is fairly simple and straightforward to make sure that we are all understanding the concepts of the tools we talk about today. But you may have a full section using a full assembly through the whole area, but you have on occasion a ditch that needs to be produced, or a variance between a flat bottom ditch to a V bottom ditch, to where you don't just have one target found, but you actually have multiple different types of targets found subassemblies on a given region and a given assembly used for a project. Having worked on multiple DOT projects in the state of Indiana, I can promise you I've used those scenarios on a regular basis. So Civil 3D cannot just automatically assume that where you have a target found, that it should stop producing the target not found. We have to physically tell it. So I'm going to select from drawing on my right side and make sure that where I stopped producing my curb and gutter, I'm now going to produce my drive sections. And then on the left side, where I started producing my drive sections, I'm going to come back through and select those same targets to tell Civil 3D to stop producing my curb and gutter and sidewalk and daylight. And if I do everything properly, then we're going to see where our corridor accommodates that, and it stops daylighting where I've got a drive approach, and I don't have any conflicting or gaps within my corridor assembly. Might look a little goofy for those who are used to having a roll curb or a mountable curb where you have drive approaches. And certainly there's an opportunity to use a marked point or use other tools to define a drive approach, whether that be at a chamfer or at a radius. We could certainly take this to another level of detail if the project necessitated it. Most people that I talk to, I openly and adamantly say, just because Civil 3D can doesn't mean that you should. And certainly we can do just about everything we could ever imagine inside of Civil 3D. But whenever we're on a lump sum project, or when we've got a client that wants us to minimize the number of hours that we apply, or we have a cap of the number of hours and an hourly project that we can apply, just because we can design to a level of detail doesn't mean we should. And if we're cutting 50-foot cross sections and maybe supplementary drive cross sections, then we just need to make sure that we have an accurate model that's going to be represented in our quantities and in our cross sections on a project under those circumstances. So we're going to stick with this for the time being, and we're going to talk a little bit more about our targeting options. Certainly, I could set a feature line out in space and define that as my right-of-way or my target line for my horizontal and vertical location for my back drives. If I select my edit targets and that region, certainly I have slope and elevation targets with appropriately named subassemblies that you can easily identify inside the software. So I do have a drive tie-in right, which will be where my actual driveway projects out and ties into an existing grade elevation under reconstruction circumstances, or a proposed site grade for maybe a residential or commercial development. Same thing on the left, etc. So where we can define those horizontal and vertical offsets. But that's a process, right? We have to continue to identify those targets, continue to identify that geometry. And one of the aspects of that is the time it takes to go through and assess and set those targets, especially whenever the design changes and we have additional targets that need to be created. One of the options that we didn't explore when first setting up the targeting, and to explore it fairly quickly, I'm going to actually remove the targets on my left side for the time being. So I'm going to remove the targets for my target found and my target not found on the left side of the roadway, just to explore one of our other options for defining and selecting targets. It's often thought of as a little bit faster, especially on very large projects, especially on very complex projects, that we can select objects instead of manually inside the software. We can do so by layer. And some of the firms that I've worked for and with have taken this to the extremes and to their benefit. They have a different layer name. If I go to properties, they have a different layer name for each type of target that they use, whether it be a drive conditional target, or a physical width target, or it's a feature line style on a specified layer for offset and elevation targets. Nothing wrong with that whatsoever. And that's why these example drive locations that we're looking at on the left side. If we could look at the ribbon or the properties palette, it doesn't matter. We can see that those are all on a very specific layer. And the reason for setting that up is that in Civil 3D, especially if we have miles long corridor projects where we have multiple polylines representing our drive approaches, especially on a county road or a state highway, or for that matter, a local residential neighborhood where we're doing a reconstruction. We can go to edit targets, and within the target mapping dialog, instead of selecting each polyline individually, we can go to our target offset and select by layer. Now, if we have specific geometry, and Civil 3D does a great job of identifying that I only have targetable geometry on 2 different layers inside the software right now. On a more complex project, where you have a lot of different targeting and a lot of different targeting layers already preloaded into your drawing, this may be a much longer list. I kept things simple today, but we have some break lines and we have some polylines that are targetable. And here is the layer that I want to identify. We have 6 entities on here. And if I click yes and okay, one thing that you have to be very careful of is there are 6 polylines selected now, all on the same layer, because while I was specific about the layer that I put these polylines on, I did not discern between 2 different layers based on what is on the left side of the road versus what's on the right side of the road. So it's picking up all those targets. So we need to make sure that we're also using targets on the same side as the subassembly and that we're not crossing over the software. Otherwise, we have to go back and figure out which polyline is polyline 1, which polyline is polyline 2, and polyline 6. So either we have to use this checkbox very carefully and intentionally, or we have to name our layers very intentionally between our targets that are on the left or the right side, or we end up with corrupted targeting and region information that kind of crisscrosses our project. Okay, so we did that for the target found. We have to do the same thing for our target not found. Select by layer, corridor target drive, make sure that we're only using the targets on the same side as the subassembly that we're creating a target for. And then okay, and then we can see we have, ooh, it is not doing what I expected it to do in one location, and it's because of our frequency, but that's okay. At least you saw the information as it was applied by using objects by layer to quickly add additional targets. What if we add additional drive approaches, or we remove them, or our design changes? Even though we added targets by a layer, Civil 3D does not hold on to that information. I can't just keep adding more objects by that layer to my drawing and expect Civil 3D to update and to account for that targeting. So I go to corridors, I look at my actual corridor entity, and it's not updating me. It's not telling me that my corridor is out of date. I have to manually map those back into my corridor targeting. Now, would you have a drive every 10 feet or every 20 feet? No, but certainly we have miles long projects to where we have drives every 100 feet or every few hundred feet. And we certainly find new locations for drives that need to be placed in a project as we proceed through a project. I've seen it done a dozen times, and I'll see it another dozen times before I'm through. So if we do have additional drives to add, now we have to go back to edit targets again. We have to go back to the specific targets that we want to place. I would tell you that the other option besides adding them by layer, because now it's not going to let you select a polyline twice. It can only belong as a target once to a given subassembly. But we do have to start to figure out, well, which ones do I have selected and which ones do I not have selected? So oftentimes I've talked to folks and they just say, I delete and clear out the polylines that I'm using or the feature lines that I'm using as my targets. And I come back in and I use a window selection or I use an individual selection on those. Again, if you're specific about the layers that things are on, you can make things a little bit easier on yourself, left or right, by selecting by layer. But just because it belongs to that layer does not mean that it's automatically added back in to your list of targets for that subassembly and that conditional to take effect. So we say, okay, and at least through that manual effort, we have our drives back and we can start to build off of those again. So not the cleanest thing in the world, but also not the longest process in the world either. So what are we talking about here? Why do we have to go through and edit all of those things manually if Civil 3D is supposed to be so smart? It is smart, but it's limited to the programming and the user inputs that we have available to us. And what we have available to us is more of a manual process, whether by individual selection or selection by layer of a static group of objects that are connected to our corridor targeting. So taking a step back here, I'm going to remove a couple of these additional targets that I copied just so that we can explore what we can do with some other tools that are available to us. Delete those polylines, our corridor updates. And just for the sake of argument really quick, for those who are joining us who've never used the tools before, Civil 3D is incredibly dynamic. If one of our drives stretches, if this represents the back of the drive or the front of the drive, depending on how you're defining it, and the width of the drive, the approach changes, well, guess what? We're able to rebuild the corridor and our targeting updates to account for that new width of the drive. So yes, Civil 3D is still very intelligent. Yes, the polylines that we used for conditional targeting are also intelligent by way of being connected to the corridor, but we're limited to the number of objects and the names of those objects in the software. And that really comes back to the basis of what a drawing file is. A drawing file in its most basic nature is a database, and then Civil 3D and AutoCAD is a software that renders all of the data from that database on our screen in these shapes and in these connected model objects. That's really what our prospector panel or our prospector tab of the tool space represents for us. It's our own kind of vision into the hierarchy of the database that Civil 3D is built on top of. Well, you saw it before, even if you weren't paying too much attention or didn't understand the significance of it, that each one of these polylines that's inside the targeting group has a name associated to it. Polyline 1, Polyline 2. And if you copy polylines, because of the database, they're going to have their own unique identifier, but copied polylines, you may end up with Polyline 1, Polyline 1, Polyline 1 as you copy those around. Not that there's anything inherently wrong with that. It's just how Civil 3D and the AutoCAD database categorizes that object inside the software. Call it a limitation, call it a feature. It's just what it does. It will have its own unique identifier in a database somewhere, but it doesn't use that unique identifier for its name inside the width and offset target dialog. Or for that matter, if we were looking at the outside elevation targets, if we selected items from the list there, it would be the same scenario. It's going to use that object name, just like our feature lines. If we don't name our feature line as targets in Civil 3D, it'll name it for us. And at least our feature lines will have a unique name by way of being a Civil 3D model entity rather than an AutoCAD drawing entity. Okay, so we have 4 drive approaches on the left, 2 drive approaches on the right. If I copy any of this line work, or if I create a new, and let me even set my layer current to my corridor target layer that I want to place, and heck, I'll even draw my polyline at the correct width. I'll define my start point, and it doesn't have to be at the edge of pavement. I think we all know that if we've been using the software for a while, but if I set my width, beginning and end width to that 2-foot value, and I'm out here in space, great, I've got another line that represents my drive location, and it's on the correct layer. It's even styled the exact same way as my other drive approaches were. The fact that it's out in space is irrelevant. Civil 3D targeting is based off of the perpendicular orientation of this geometry to the alignment. So it's really just a matter of how this polyline orients to the perpendicular station of our baseline. So our conditional targets could be 100 feet away from our edge of pavement. And as long as the stationing values are correct, then our conditional targeting is going to be correct. But the problem I have here, and the problem that you're probably running into, is how do I more quickly add new targets or copied targets back into my corridor targeting? And there's a tool for that. It's just, unfortunately, it's not available out of the box. It's a third-party tool through CTC Tools, specifically the SIM project suite. Everybody who's followed ATG for any amount of time knows that we're massive fans of the folks over at CTC, and that we enjoy our ability to share these tools with all the folks out there in the industry who rely on them to do their jobs better and faster. So we have in this particular drawing some offset, some width targets, some conditional targets. Again, a pretty simple example for the sake of us joining each other over a lunch hour for a very short video to review the use of these tools and best practices. So let me, as opposed to removing all of these targets, pull some Food Network magic, and I'll just open up the original version of the drawing just as a duplicate. And we'll kind of start back over and see how we can use some SIM project suite tools to speed this process up for us and better manage the process over the course of a project. Same assembly, same subassemblies, same names for those assemblies and subassemblies if we're looking at them. Exact same polyline entities, even on the same layer as before. If I'm looking at my home tab and I'm looking at my layer, everything's on the same layer, exact same setup as we had previously. So Food Network magic, but it's all on the up and up. If we go to SIM Project Suite, we have the ability under the corridor mapping tools to create layers specific to the assemblies that we're using on a project. So that whenever we're talking about unique layer names that are specific to the left and the right side, and the types of offsets and the types of geometry and the types of subassemblies that we need to adjust widths and elevations and conditional targeting for, that could take some time, right? You have to come up with a corporate standard for layer names and building those out. And do you include those in your template, or is it a part of a tool palette block that gets inserted so that you get those layers whenever you need them? Forget all that. You are going to have very explicit names, and at least from a best practices standpoint, very explicit names for your subassembly objects. Inside lane right, inside lane left, my conditional targeting for the right and the left side, the sidewalk itself. You know, we're taking the time to label these things specifically. Of course, I show urban, curb, and gutter general, which I never create unique names for, simply because there's nothing to target within the corridor targeting for it. But everything else has very specific names. If I hover over and look at tooltips, sure, you can see all those names that way too. Because we take the time to label and name our subassemblies specifically, we should use that to our advantage. And the corridor mapping, the SIM project suite tools allow us to create layers in our drawing from our subassemblies. So layers from subassemblies, follow the command line prompts, select assemblies and subassemblies in your drawing, hit enter. Now you can see all of the different subassembly entities that are used as part of this one assembly I have in this drawing, and the associated layers. Now, if you're anything like me, and I hope you are in this aspect at least, you are using very similar assemblies throughout a project with very similar, if not identical, subassembly names that just happen to be used in separate regions. That's great. That means that you don't have to have an infinite number of new layers added. If you have a tree lawn left and a tree lawn right that exists in 5 different assemblies, then there's no reason to have 5 different layers that are added to this list. So good drawing practices and good naming practices play into this as well, but we're building up to the use of these CTC tools in a way that probably is going to make your life quite a bit easier for the initial targeting, as well as the long-term maintenance of your corridor. So we'll go ahead and click OK. And Civil 3D, if I look at my layer property list and scroll a little bit, I'm going to see that I have all of those subassembly names now created as target layers that I can utilize in my software. So if I had a conditional target left for my drives, I would place all of these polylines, either create them from scratch or take the ones that I already have, and I would place them on that associated layer. And there's a number of ways that you can move an object from one layer to another, but we have, bear with me for just a moment, our target found, drive left. And we have our target found, drive right. So I'll jump down and make sure that I'm setting up, again, alphabetical. I should be able to find these a little bit faster than what I did that first time, but we've got our target found, drive left, and our target found, drive right, because we intelligibly named our conditional subassemblies appropriately. Same thing for this alignment. Yes, your alignments generally are going to be on associated layers, but if you're using them explicitly for targeting purposes, you can certainly add alignment or change the alignment layer that it lands on to the associated target layer that you're ultimately going to shift to. So if it's an inside lane left, or if that's going to target the width on the left side here, and the width of the offset here, again, I'm not changing the style. The style is still overriding the way it looks in the drawing, thankfully. So if I need to maintain the style, changing the layer it's on is not going to override that. But I do have it on the associated layer that I need for automating and creating a link between the CTC corridor mapper tool and my actual corridor. So now if I either select it before or after, let's look at it both ways, honestly. Corridor mapper, rename layers and subassemblies. We can certainly go in and start to do that if need be, but we've already gone through and attempted that. We don't need to rename our subassemblies because we already had well-named subassemblies. We don't need to rename layers because we created the layer names from the subassemblies that we've already named accordingly. So what about auto mapping targets? That's where the money's at, right here. Select the corridor that you want to map the targets for. The corridor does not have any targets mapped. Do we want to map them now? Absolutely. So in our CTC corridor mapper dialog, we can automatically map the layers. Note that the subassembly name now matches the layer name. Auto map layers for width and offset targets. So there's our surface targets. Here's our width and offset targets. All of those are mapped accordingly now. So if I have anything on those layers that I produce, and note that we do have a couple, we have some target not found and some target founds, I'm not going to duplicate. Now here's the trick. Our conditional assemblies, I'm not going to duplicate two different objects on two different layers for my target found and my target not found. So I do have to override that. I do want to make sure that my targeting does match, and I can use the rename function for it if need be as well. So if my target not found that it found two targets on, I need to make sure that my target found drive right finds that same layer on the right side to ensure that it's picking up those same two targets for reducing the correct subassembly and to stop producing the incorrect subassembly in that location. And the same thing is going to be true for my between my right side and my left side. And again, this dialog box, just like the other that we were working with before, right and left, expand your columns to where you can see everything and make good use of it. There's my target found drive left. It found that appropriate layer. Target found drive left, found that appropriate layer, and it automatically mapped everything else accordingly. Auto map layers for slope and elevations. We don't have any feature lines or 3D polylines in this drawing to define those by, but it obviously picked up all those layers. As soon as we added something to those layers, it had found it. It had done great work. Click OK. It's going to recognize all of the targets that we found. I'm actually probably going to drop my my surface targets because I didn't actually develop any additional surface targeting outside of our, there we go, 14 width and offset targets, 0 surface targets. And there we go. Because it didn't find any surface targets, I probably do need to go back and edit my overall surface targets. And that was my fault for even setting those, for even automatically mapping those whenever I didn't have anything on a surface for it to capture on those layers. I just have my EG. daylight right, daylight left, I could have mapped those to the layer that the existing surface was on instead of using the subassembly names, and it worked perfectly well. Or I could have just chosen to not auto map those because they were already targeting the right thing to begin with. But my left and my right side are currently targeted, not just my conditionals, but also my width offsets or my widened offsets for my right-hand turn lanes. Take it a step further, and this doesn't seem on its face value any more fantastical than what we saw before with manually mapping things, except for we didn't have to create new layer names. We don't have to manage our list of layer names, and we can quickly apply things to the appropriate layer, and our corridor mapping is going to automatically update. Additionally, if I take one of my drives that is on the specified layer and I need to add another one anywhere in the project, it doesn't matter where, that's fine. I just go back to my corridor mapper tool and auto map my targets and select the corridor, and it's going to find the additional information. Look, and now it's finding 16 offsets on the left where it didn't before. Why 16? Because it's going to be an even number for our conditional targets. It was 14 before, it's 16 now, because even though I added just one additional drive, that's going to represent the geometry for my target found and my target not found on the left side. So that's proof in the pudding in and of itself. Let me go back to corridor mapper really quick. It's to set up the targets. One of the things that I'm going to do is I'm going to change my layer target for my surface. Since it's already defined, I don't need that to override every time. And if I do that now, then I prevent losing my surface targeting each time. Okay. Also note the box that we have down at the bottom, use targets on the same side as the subassembly. We use that in the out of the box corridor targeting. We've got that same tool available to us here. And this kind of reinforces using the corridor mapper tool from what I mentioned before. Yes, it's using corridor mapper, but you can have a target anywhere out in space. Civil 3D is going to recognize its perpendicular station values and station limits to produce where that that actual conditional geometry is going to take place. So this is just one, and it's just on the left side. But we know that we don't just have drives. Sometimes we have barriers. Sometimes we have curb that needs to be produced. Sometimes we switch from curb and gutter to a shoulder. We have different conditions that we hit within a corridor that using this corridor mapper would be extremely beneficial from. And if we have those conditions on set station values, then there's absolutely nothing preventing you from doing regular AutoCAD copy and pastes or drawing geometry on the correct layer using the station offset transparent command to ensure that you've got the correct station ranges. And every time you do that, rather than just simply adding the clicking rebuild on the corridor, if you just go to your corridor mapper and map your targets again, it's going to find all the new targets. It's going to pick up all the conditionals, target found, target not found, and it's going to repurpose those. And that's it. There are some new things coming your way that are currently in beta that I can't wait to show you in the future. You may have seen some of those CTC tools for the mapping utility shown during some of the virtual AU sessions that happened late in the fall. We've got some great things coming your way for automatically developing widening targets beyond just layer selection, but by object type. So if you have a widened alignment, you don't have to worry about the layer that it's on. You can use that as an additional confirming factor for how you decipher between what kind of targets are used. But we can do all sorts of new things with the next version of the corridor mapper that's going to be coming out and available soon to where we can select by object type and differ the kinds of conditionals and the kinds of width and elevation targets that we apply. But this right here, just what you've seen today with the corridor mapping, saves you a ton of time in developing and managing your layer list. It saves you a ton of time for going back into constantly reconnecting and re-editing your targets. It's static, it's great for out-of-the-box work if you don't know any better, but as soon as you know about these CTC tools and the corridor mapper and the ability to create additional geometry and just synchronize everything dynamically without having to manage which items are a part and which ones aren't currently a part of the selected list, and who cares what the polyline name is. Is it polyline 1, 2, or 3, feature line 5, 6, or 7? It doesn't matter anymore with the SIM project suite and the corridor mapper tool. So with that said, there we go. Nope, not good. There we go. You want to see more great content like this, you want to come back to us and see additional videos about CTC tools, Civil 3D, anything from our Revit and our architecture, structural, MEP teams, or even our reality capture team. We've got some great videos that we put out every single week. Stay in the loop by connecting with ATG on LinkedIn. Get 24/7 access to our library of YouTube videos at our YouTube channel at ATG USA. There's a ton of great stuff out there. We love to expose you to the options that you have as users. We love to improve your ability to use the software as it stands, as well as expose you to other options like what we have out of our CTC project and SIM manager suites. So please stay tuned to those, subscribe, and we look forward to seeing you again in the future. I appreciate your time today. Thank you. If you want to connect with me, my email address is listed on this final slide, and there's my LinkedIn profile. Feel free to connect. I certainly share the videos that our team on the civil side of the ATG group publishes on a regular basis. You'll see our white papers, you'll see our webinars, as well as blog posts that you can use to improve your skill set and work better every single day in what you do and what you love to do. That's all from me. Thanks for your time, and we look forward to seeing you the next time around on an ATG live webinar much like this one.